Hello, we're back. As you can see, there are a bunch of resistors. And I'm gonna turn on the soldering iron. Soldering iron is heating up because we're gonna do some more soldering, because apparently we're not done. Because I forgot about a thing. We're gonna be switching this thing with 3.3 volts from the RPi here. And I did the simulations with 5 volts. RIP. So when I substituted in 3 volts, 3.3 volts in the simulation, it doesn't saturate the bridge. So, and it pulls a lot less current, and it's just not gonna work. So we need some kind of level shifter or some kind of buffer. Now, ideally you do this with PNP transistor, but I don't have PNP transistors, so I'm just going to use 2 NPN transistors instead. Let's go over to this. Here's the circuit that I've built up around the original H-bridge, which is here in the center. There's the diode you recognize. Now what's added here is that on the top driver here, on the top part of the H-bridge driver, there's 1K to the 5 volt supply, and then here is a normal NPN transistor hooked to ground, which is gonna pull this down if it's activated. And it's going to be normally be activated by this 200K pull-up. That's going to be pulled down by this transistor, which is going to be activated by these. And that's symmetrical on both sides. Now, if you're using an NPN transistor right here, this is going to be an inverting input or inverting output, because you input a voltage, you turn on the transistor, it pulls this to ground, which makes this output a 0 volts, well, very close to 0. And if you leave this, well, non-energized, this is not going to turn on. This is going to be slowly pulled up to 5 volts, and the output is going to be 5 volts. So it's an inverting setup with NPN transistors. You can get away with using just one stage, maybe. Maybe the gain isn't high enough. I haven't tried, I'm not gonna try. All I have is NPN transistors, so that's what I'm gonna use. Now the reason for the 1K here is because if I have any higher, it's not gonna saturate the transistor. Which is kind of rip, but I'll deal with it, and that essentially these 2 resistors here essentially turns into standby current things. They're gonna continuously be, either this one is gonna be hooked up directly to ground and be draining about 4 milliamps or so to ground all the time, or this one. This is not gonna be enough, a lot. But when this one is on, then this entire circuit is also on. So when the circuit is on, it pulls current. When the circuit is off, it also pulls current, so rip. I was kind of hoping I could get a very low standby current, but that doesn't seem possible with the low amount of components I want to use for this. I still want to debug this in a way. But yes, let's run it, and and immediately you can see we have current flowing, even though nothing is on. And that's because of these 1Ks, and they're being pulled down, and they're passing about 4.3 milliamps, which is a total about 8.7 milliamps standby current. That's quite a lot, to be honest. But I don't really know any better way to do this with only NPN transistors. But anyway, over here we have our 3 volt supplies, and it's only 3 volt, not 3.3. Well, that doesn't matter. Well, let's just for clarity. 3.3 volts. And we're going to activate one side, and as you see, if we activate this side, this turns on, grounds this, turns this off, brings it into cutoff, which allows this transistor to be pulled up by this 1K and to be saturated. Now if we change this to anything else like 1.1K, oops, it's gonna be, oh, it's saturated now, what the hell. Oh yeah, it's saturated up to 1.2K, I think. Yeah, still at saturation. But if you go over that to like 1.3K, it's now running in the linear region and it's dissipating 40 milliwatts. Instead of here where it's, well, not much different to be honest, 38 milliwatts. But I chose to round that down to 1K. And yeah, the rest of the circuit is basically the same. I tried using diode there, but it doesn't work because of resistances and stuff. And how these devices work. Let's try it the other way, works fine. And if we go down to really slow speeds and turn it off, you'll see that it will discharge through 1.2K in the motor itself and one of the transistors from the base to the collector with that parasitic diode. But yes, this is what we'll try and debug together today somehow. Yeah. So let's get to it, and these 1Ks here are just to prevent the base emitter current to, well, become infinite, essentially. Yeah, it will become infinite in this simulation because there's no resistances otherwise. This would work up to down to 1 ohm, I bet. It's gonna piss a lot of current. Yeah, 2 amps. Yeah, control lines that pull 2 amps. That's unfortunate. Also, this motor is probably not 50 ohms, it's probably 20 ohms. And wow, that's inefficient. What? Oh, just a few microamps. Wait, is it still? Oh yeah, we're running really slow. That's why. I'm like, why is this so slow? But it's just... Okay, yes, there we go. 120 milliamps. 140 milliamps. This is all from 5 volts at the maximum. Oh, and short current circuit is 600 milliamps. Whoa. Anyway, let's build it. And for that, we shall go over to the physical world. Hopefully that soldering iron is heated. And we shall first of all open that claw, and then we'll disconnect all of this. Come on. There we go. I have to cut these things hanging off as well. That is not okay. Health and safety requires me to remind you that this is not safe at all. Actually, do they require that? Who knows? Do I have something I can cut with? Can I cut this? Could you please be cut? There you go, a bit cleaner, not by much. But remember, this is our bridge structure right here. Here's the top two, here's the bottom two, that's the top diode. Well, it's a resistor, but it's no, it's a transistor, but it's working as a diode. Don't mind that. And let's rotate you so you're not completely in the way. And let's look at these resistors I've picked out. Here we have 100K, 1.1K, 180K, 1K. This must be 200, yes, 200K. So 2 of these, 4 of these. These are just backups. I think that will... Oh, and a bunch of transistors. We need the transistors. Where are the there the transistors are. Let's open this bag of generic 2N3904 NPN transistors, and 4 right there will be more than enough. Let's check if these are actually 2N3904. Yes, they are. What's that other number? And is it the same? Two N3904 B or H 331. So yeah, that's the specific make and model, I guess, or factory ID or whatever. What is that extra number even? I never know. So let me pan over here. Crush some Lego in the process. Let's look at the schematic. And let's rationalize something here. Let's... I don't know, should we start building from the H bridge and out towards the IO port? Or the other way around? Or should we build it as 2 separate modules and attach it? intensifies. I mean, if I look at this, what was this? This was 1K. Let's get 2 of these. These are ready. Damn glue on these. If you can, just cut the glued pieces of the pins off. It's much easier. So here we have 200K. Is orange too? I didn't know orange was 2. Brown, orange, black, black, red. I can't read this. But that doesn't matter. I have a multimeter. I can trust that. Yes. And yes, it's newly calibrated. Yeah, it's all right. So I guess I'll just start. Okay, let's not get too hasty here. Let's actually plan. Let's take one of these. We have decided that emitter is at this pin. And here the collector must be at the base for that one. What the how can I do this? Ugh. Okay, I guess that works. I'm gonna pierce myself or something. This is not safe. So, we'll start with the 1K stage. Wait, where's the other 200K resistor? Where did I left that? There's one. Where's the other one? Did I just put it down and lose it? What? Where? I am of the confused. What happened? What? Oh, there. It's one in front of me. Yes, it was. And I dropped it on the ground. And it seems that it stayed down. Whoop. Oh, seriously, where did it go? Ah, there it is. Yep. Take those away. Put that away. Don't leave that. Pull out 2 of these. So basically, this to there. Oh boy. This dead bug can only. This is so bad. Let's go. Where's my solder? So little solder on the roll now, so it just keeps falling over. First of all, let's tin this. enough. Second of all, ow. This blue heat guard here doesn't work. I'm just gonna tell you that right now. I guess we could build both stages simultaneously. Or should we? That's gonna put a lot of stress on these cables. Need flux. Seriously, I need some flux. So I don't have to rely on the stuff that's in the freaking spool. So that's tinned. This is brown, brown, 0, black, black, brown. What does brown mean when it comes to accuracy? Is that like 10% or something? Well, brown is 1, so 1% or 10%. No, 1% is more silvery or gold colors, maybe. I don't know. Let's just say I've never learned resistor color codes. I need a better sponge. I don't wet the sponge, I just use it dry. Maybe that's a mistake. Oh Lord. Well, let's get this abomination stuck together. Wow, it actually stuck down with that little solder. I'm actually amazed. That's hot. Too hot. Oh, and let's build out the other stage. Ow. Horrible. Whoop. Okay. That gives me kind of a ledge though to put this on. There we go. Who needs rough symmetry? Actually, I kind of need rough symmetry. Let's see here. Collectors where? That's collector. The connector to that, and okay, oh, I guess I'm just splaying the legs out as a T again, and I'll lay it from this collector, from this base here down to ground. So fashionable sense. Essentially down to this pin. Like that. Maybe. There. Oh, that's risky. I think I'm actually gonna pre-tin these two lanes. Solar blob, get up. No. Get. No. You don't belong on the table. You shouldn't be here. There we go. Okay. So let's check the orientation of that one, and that one is correct. And that's according to that. We shall put it like that and rotate it about like that. Maybe even this is stupid. I need something to hold with. come on. No, don't do this now. It's barely on there. Let me fix this by tinning this side. And then forcing that down there. There we go. Now I can fix this up here by essentially moving it back. Okay. And for the other side, bend out, bend out. This must go there. Oh, it must go all the way over there even. Oh shoot. There's a bit of a space complaint here. Let's fix that by just not caring and work around it. So we're gonna tin this. Like so. Ouch. And we're gonna check the correct orientation for this one, which would imply that the top pin right now should be the one that should be soldered, so we're gonna tin that. And let's assemble it. Let's just jam it in there. It's all the work with the component. Let's roughly line them up. Now let's bend the fuck out of it. That's hut. Okay. Guess that works. Oh my god. This looks horrible. It's horrible. I'm sorry. I'm so sorry. Fuck. Okay, so technically, if we power this driver up now, it's gonna short itself because of these two transistors we just added they invert their output and their input is none, so both of their outputs are gonna be high, which means that both sides of the bridge is gonna be on, which is not good. Let me just tell that. So yes, let's continue on. And let's attach the 200Ks and their equivalent resistor. So first let's do some figuring here. Don't want to get this too close to the soldering iron. But we're gonna need another tap up here from 5 volts down now here to this base. And then from this base to a transistor, which also goes to ground here. So we're gonna have to make this a long boy. About that long. We're probably also gonna have to cut some wires. Let's cut these. Bit of the way up, of course. These though, no use. These, no use. This is no use. Just separating a bit, making sure the sides are separate. And yeah, let's get down to these two, I guess. Yeah, I think that'll do. We can run alongside like this. Actually, let's bend another transistor. And the same deal with that, which is the collector on there hooks through the ground, through the emitter. Wait, so their emitters are basically hooked together. I can do this. So it's an inverse Darlington with a pull-up. Okay, good to know. I need to get that in there somehow. Maybe even... about a 90-degree turn like that. That works. This is the pain with soldering. You don't have free hands. You need free hands for this. Oh my fucking god. Make sure it's the correct way around. And we'll solder it in, I guess. Fuck, this isn't gonna work. Let's do it anyway. Yep, this is not working. Oh, come on. They're just messing with me. Please stop, physics. Or do you want me to, like, use a different grip? Or what do you want, physics? Physics! Calm the fuck on, just... Double check orientation again. And go for it before physics sees what I'm doing. Be fast as hell, be fast as hell, be fast as hell. Don't worry about that separation, the solder is still holding it on. It's good enough. You might actually have to push that down in again. Let's somehow get this connected to this. How the fuck is this gonna work? Well, apparently like so. Wonder if I can just hook it in here. Seems like no. Well, that makes me very sad. So sad. So sad. Let's approximate that distance and tin it. Perfect. Let's get it on there and let's leave it. I need to flip this again. Also, I'm pretty much unavailable in chat, if you haven't noticed, if there's anyone there. I doubt it, but who knows. Alright. From there. Come on. No, come on. Good. Want the definition of annoying? Look up copper cable. Actually, just cables in general. That was one of the worst solder joints I've ever done. But that's just gonna have to do. I shouldn't have bent that in the first place. Fuck. Are you serious? What happened there? No, seriously, what happened? Just... be straight, kindly. Wow! If we power this thing up now, it should just run, because we've completed one side, so it should be off. The other side is half completed, so it should just turn on. Theoretically, at least. So it should not short, it should either close or open. When I apply power. So let's apply ground. And let's apply power. And we seem to have an oscillator. It's just oscillating. Hold on, I'm gonna I'm gonna pull this other side up. And suddenly it draws nothing. And now it beeps and pulls 110 milliamps. I don't know. Seems there's some RF type stuff going on here. I shall attach this 200K to the other side as a pull-up, and then I'll test the other side and see if it has gone blam or something like that. Wait, what? Yes. Solar. This is no good way to hold things. That's better. Maybe I shouldn't rest my hand on the robot. Something cracked. Yeah, that's in there. Let's... I don't know. Actually, I can still hear that same tone. I think it's interference on the mains, actually. Or I'm just acting as a big-ass home antenna for some equipment in my house or something rather. Well, probably. That's an even worse angle. Oh god, that looks weird. My depth vision is failing me hard. This looks very weird and trippy. Oh, that's why. Confused brain is confused. Anyway, let's hook it up again. -2, negative, +2, positive. We're pulling 10 milliamps, which we should. No, we're pulling 100 milliamps. What the hell is happening? What? Why is it pulling 100 milliamps right now? This should not be. How do I? Okay, I pull you to ground. Not a single iota happens. But why are we pulling 100 milliamps? We shouldn't be pulling 100 milliamps. What's pulling 100 milliamps? Now it's pulling 0. What? Oh, because of that. Still 100 milliamps. What? Seriously, what is pulling that current? Something is dissipating the heat. What is it? Nothing here is getting fiercely warm. It should... Oh, and... Do we have a bad solder? We do! That makes all a lot more sense. Let's test that again. Here's the ground. It's pulling 0, right? Oh, I think it's actually working. I shall get another 1K. And I shall hook that up to this probe here, and we shall use that temporarily. Okay. That makes sense, that side isn't complete. Oh, and that side is complete, so it should be inverted. So it should be pulled to 5 volts via the resistor. 120 milliamps. Now let's hook back to ground and ground this, because that's what this resistor transistor expects, and let's see if it goes. Have I actually stuck it or something? What's happening? There's some sort of oscillation in here. Oh, an amp? What? Okay. Why isn't it moving? It should be moving. Okay. What was that all about? I don't want to do the voltage checking. No, damn it. F. What's wrong here? Thou shalt check voltages. You should be at cutoff. Why aren't you at cutoff? You even what? Why aren't these at cutoff? What? This sucks. Oh, shorting it like that probably wasn't good. Why? Why does it start to oscillate? And it works in one direction but not the other. Varför? Why? You're pulling a lot more current, but you're weaker than before. What happened? Before you could move yourself and the claw. Now you can't even move yourself. And you're pulling less. How the fuck do you manage? Honestly. I think I made some kind of receiver accidentally. I mean, given the transistor configuration, there's basically a astable oscillator in there. But why doesn't it want to work? I mean, seriously, why? $70 milliamps, 80 milliamps, 90 milliamps. $90 milliamps. Yeah. It doesn't have the kick. I am quite honestly disheartened. Everything is correct. Here, this is what we have, essentially. This is what we have so far. We have everything except this transistor and the connections to it. And this runs. I'm pretty sure this runs. So I have that idle current of 8 milliamps. 8, 7, 8, yes. We activate this. It's still gonna work like normal. Why doesn't it work? It's because the equivalent series resistance of this thing is like 1. No, I did hit 1, but 5 is fine too. I don't see any oscillation at that beginning, so I don't see how there could be oscillation. $439. I am very saddened. Oh, look at that. That one is not in saturation. I bet it's not really needed, but yes, I'm sure it's in saturation. Okay, let's just go F and just say fuck it and just say 1 Henry and just have at it also. Would you kindly not lag like this? Okay, let's check what happens. It backfeeds through here, so maybe we do actually need to finish this stage here so it can backfeed correctly on both sides. Or I can just turn up the voltage. We're now at 7 volts. I thought I could actually hear it, but I could not. Let's... What the f... I'm not gonna tolerate spamming the output to get it to go as a fix. That's not a fix. And I crashed the power supply. Yeah, it's really crashed. There we go, unplugged. Plug in. Turn on. Well, screen is fine now. And there the fan goes, okay. We're just a bit hot. Okay, let's pull down to 5 volts and see if I can get it to start again. By spamming it, because there's some sort of oscillation going on in here. Okay, I'm just gonna turn up the voltage. 9, 10 volts. Okay, at 10 volts it works perfectly. Actually, no. Yeah, it's still there. What? In the name of actual fuck? When it beeps, it's a sensor for rotation inertia things. What? Well then. I guess I have some issues to work out. That's at 5 volts. It has the current to be able to start. But because of the oscillation, I assume, it's just not being able to turn on one of the two bottom transistors determinately, and they're just both on. I guess. Sometimes they get going again. Sometimes it just stops like this. But then it pretty much starts once you start tapping it. There you go. Different tones when I grab it and twist it backwards. What? Okay, here's how a motor sounds normally. That was forwards, backwards, and forwards and backwards. No, this is the same motor but powered on through some weird oscillator effect. Hear that little whistle it does? It's weird. So I guess the coil in here is acting as, well, the frequency holder, and this mess here is acting as a greater than 1 stage amplifier, which keeps the oscillation going, and apparently can be affected by moving. the frequency can be affected by moving some of the components or touching them. And the power supply seems to have crashed again. Have you actually crashed? No, you're fine. So here's the thing. I think that the bottom two transistors here are turning on both at the same time because of some oscillation in the motor. Can this... Because when the motor runs like this, it's pulling 40 milliamps, and when I do... Whoops. And when I do this and pull down, it pulls 70 milliamps. But when I stop it and do nothing, it pulls 111 milliamps. No, 110. And when it's off, it's 40 milliamps. No, it's 110. So it's kind of like both of the sides are activated at the same time on the bottom side. So yeah, I guess I'll be back soon. Yes, I think I'll stop the stream here and I shall do some more research into oscillations and how to cancel them. Is the pitch going down? Why is the pitch going down? Is it heating up? Where did that 1K go? I kinda need that right now. I need that 1K. Fuck it, this is good enough. Whatever this is. And I need from... Yeah, this is perfect. Now when I tap on it, it doesn't want to go. This is weird. God damn it. Well, at least it's... kind of like an engine you have to manually start. Yeah, I think I'm gonna sit down and think through this and figure out something with those bottom two transistors. Maybe it wasn't the best idea to have them be activated by their top counterparts. Maybe they should have been directly activated. Well, gosh darn it. Yeah, this circuit is weird, and I don't recommend you build it unless you know what the hell you're doing. Because I clearly don't. Yeah. F all over. Hey look, people was in the chat and I missed them. Someone said to give me moderator. This is not Hubble. Or like Gmod. This is not that. But yes. Since this clearly went in a bin, I'm gonna sit down and work on this. And yeah. Maybe I've estimated. Wait. How much of that did you see? I'm really scared that you saw nothing of that now. Well, as it seems, the last 20 minutes have been just the screen and nothing else. That kinda sucks. Wow. Such production quality. Oh wow. And yes. Is that now? Yeah, that's now. Yes, there is someone here, and that's me. And I think I'm just about to close this. Because this here doesn't work at all. It's self-oscillating or something. It's just not feasible. I don't know. I may have to add in some kind of, I don't know, resistor blocker or some kind of capacitor, maybe? I have no idea, to be honest. But yeah, I guess this is going on hold for a couple of hours while I research. Let's see what's happening. Yes. With that said, I'll say goodbye for a few hours.